Global demand for critical minerals and metals is rising fast, and fears of shortages are making headlines. Some argue that to secure a green transition, the answer may lie at the bottom of the ocean. Are we really on the brink of running out of essential metals? If this is the case, are there better, more efficient ways to meet demand without turning to the deep sea? Let's take a closer look at our resource needs. If we want ambitious climate action and a rapid shift to clean energy, the International Energy Agency estimates we'll need up to 60% more cobalt, 100% more nickel, 30% more copper, and over 200% more lithium in the next 20 years. There are several environments on the seafloor that contain high concentrations of valuable minerals and metals, though extracting these resources remains a technical challenge. For example, polymetallic nodules that are scattered across the deep ocean floor are rich in copper, cobalt, and nickel, along with smaller amounts of rare earth elements and lithium. However, critics warn that mining the deep sea floor could be hugely expensive with significant technical risks, which may make this option less commercially viable. Meanwhile, the full extent and potential cost of environmental damage is still unclear, though early evidence suggests the impact may be considerable. So, how do we protect the deep sea and still meet our mineral and metal needs? Maybe the real question is, how can we build a greener future with the resources we already have? First, we can increase the efficiency of traditional mining on land. There are still significant metal deposits that can be extracted from lower-grade ores using new technologies. Second, remining old waste. What was once considered unusable can now be a valuable resource as we develop ways to recover metals from mining leftovers. Third, recycling and reuse. By extending the life of products and recovering materials, we can dramatically reduce the need for new extraction. Smarter use of existing resources is essential. But could emerging technologies help reduce our reliance on critical metals and minerals altogether? Let's take a broader look at the solutions for a green transition. Over 85% of projected demand growth for key battery metals is driven by energy technologies, especially electric vehicles and grid storage. Since transport and electrification are driving demand, innovation in these areas could reshape our entire resource outlook. Take batteries, for example. Most batteries today rely on metals like cobalt, nickel, and lithium, all expensive, energy-intensive to extract, and concentrated in just a few regions, including the deep sea. But alternatives are on the horizon. Sodium-ion batteries use one of Earth's most abundant elements, along with more widely available metals like iron and manganese, making them a low-cost and promising alternative to lithium-ion technology. Researchers are also exploring zinc-air, solid-state, and aluminum-based batteries that could reduce reliance on scarce metals. Future solutions may even harness fungi to recover metals from used batteries, and energy technologies like flow batteries, mechanical storage, and thermal systems may soon offer new ways to store energy without mining new metals. By diversifying our technology choices, we open the door to cleaner, more sustainable energy systems that rely on fewer metals and smarter design. Thanks to these advances, we may be able to secure the materials we need without turning to risky new extraction industries. Yet, to truly shift course, we must go beyond substitution, cutting demand and reimagining our resource use. Building a circular economy is a smarter, safer path forward. Minerals and metals will still play a role in the green transition, but through recycling, remining, repurposing, and metal-free innovations, we can reduce our reliance on finite resources. By investing in environmentally friendly alternatives and reducing overall demand, we can secure the materials we need while protecting the planet we share.